Hello, it's Iino. I would like to broadcast Iino Sans Logistics Radio. Today, I would like to talk about the theme, Kawasaki Kisen Keisha, Mitsubishi Shipbuilding and Class NK succeed in capturing CO2 on board, for the first time in the world with some discussion. CO2 capture on land has already been established, but this is the first time in the world that CO2 has been captured at sea. On October 20th, Kawasaki Kisen Keisha, Limited and Mitsubishi Shipbuilding Corporation, in cooperation with Class NK, announced that they have successfully conducted a demonstration test of CO2 separation and capturing on board a ship. They installed a small demonstration plant on a coal ship. This demonstration plant was converted from a land-based plant for offshore use. It separates and captures 99.9% pure CO2 from the exhaust gas of the engine, and the company plans to focus on research and development, and sorting out issues for commercial use. In decarbonization, our focus has been on not emitting CO2. But in reality, it is captured and stored. The Ministry of the Environment is currently working on carbon dioxide capture, utilization and storage, CCUS. At the first international conference on CO2 capture held in Amsterdam in 1992, there was already a movement for CO2 capture. Since 2005, CCS, CO2 capture and storage, technology has become a reality. As for the method of separation and capture, CO2 is soluble in water, so it can be separated and captured by heating it in a special liquid. Recently, a method of trapping it in a solid absorber has also emerged. Mitsubishi Heavy Industries is well known for its CO2 separation and capture equipment. The company has installed recovery equipment in 14 locations around the world, and holds over 70% of the market share. It was currently stored in the ground. The captured CO2 is transported by pipeline, compressed and stored in underground reservoirs. The idea is that if the geological formation is stable, enough to contain oil and groundwater for a long time, then it should also be able to contain CO2 for a long time. However, there is a limit to where we can store it. At the current level of CO2 emissions, it is said that the world can store enough CO2 for 65 to 100 years. In Japan, there is CO2 capture and storage facility in Tomakomai, Hokkaido. Another option to store it is to liquefy CO2 and transport it by sea. It costs about $30 per ton of CO2 to collect, pipe to the storage site, and inject it. Also, as we talked about earlier, the area, geological formation, for storage is limited. If the distance between the collection point and the storage area is far, marine transportation may be less expensive than pipelines. There are only 5 liquefied CO2 ships in the world, and all are managed by the Norwegian shipping company Larvik Shipping. Originally, the ships were operated for drinking gas and other purposes. With the recent commercialization of CCUS and CCS, there has been a lot of attention worldwide. Mitsui O.S.K. Lines has invested in Larvik and entered the liquefied CO2 transportation business, and is also developing liquefied CO2 carriers in Japan. When the distance from the CO2 capture point to the storage site is about 100 to 200 kilometers, the cost of marine transportation is lower than that of pipelines. The average cost of CCS in the world is about $80 to $100 per ton of CO2 to get it into the ground. Of this, about $60 to $70 is accounted for by the separation and capturing process, and there is an urgent need to reduce the cost of this process. The entire world is working on this issue, and in Japan, the Ministry of the Environment is working on this. Separation and capturing technologies are also being developed to reduce costs. Japan is now aiming for $10 per ton by 2050. Effective utilization of CO2 is also important. In recent years, due to the development of technology, there is a movement not only to capture and store, CCS, but also to use it effectively. CCUS is also important. CO2 can be used to feed plants and vegetables in greenhouses, and have produced basic chemicals, methane, methanol, olefins, etc. Methanol has been attracting attention as a marine fuel. Maersk is also building methanol-fired ships. The EU has approved a law to increase the CO2 emission reduction in 2030 from 40% below 1990 levels to 55%. In the future, the reduction of CO2 emissions will be even stronger. In order to achieve this goal, corporations, venture capitalists, and other investors have begun investing in and partnering with CCUS companies. In 2021, CCUS companies are expected to triple their funding from the previous year, reaching $1.1 billion. In terms of decarbonization, capture and storage is taking place, but there is also a limit to where it can store. As I said at the beginning of this video, we have succeeded in recovering them at sea, so I think we will have to pay attention to CO2 capture in the future.